So welcome everybody to the January meeting for the Hamilton Amateur Astronomers. My name is Sue McLaughlin, for those of you who don't know me. And thank you to everyone who braved the weather out there tonight. It's snowing, raining, snowing. We're quite close to the lake here, so we're hoping we're going to get more rain than snow. This is our first night in our new location. This is St. Matthew's on the Plains Anglican Church Parish Hall. And so far it's working out well. It's blue like McMaster. For those of you that aren't here, it's blue and white like McMaster, but it's a little bit different, and you can tell that it is a church hall. For those of you that are here, the washrooms are, if you just go straight down the hall and to your right, there's a hallway and the washrooms are right there, and they are accessible for those of you online who I know will be coming in the future. Tonight, we have a full agenda for us, so we're going to get started. We're going to have some announcements. We have Brett Tatton and Frank Williams, our guest speakers tonight. We'll have our break. We have some door prizes, and then we have the sky this month with Matthew. And to start off tonight, we have a second guest speaker tonight, other than Frank and Brett. And I'm just going to pop over here to his PowerPoint so we can get that up and going while I'm talking. Tonight we have Tom Steckner with us, and he has been a member of the HAA for, in his words, oh dear, I don't remember how long it's been. So we figure it's probably been 20 years at least since he has been a member. And he's going to talk to us tonight about a really exciting adventure that's happening in Toronto, and it's called Space Place. And I'm just going to get this going for you here, Tom. And I'd like to invite Tom to come up and speak to us tonight about Space Place Canada.
There. Hi. Anyways, I'm Tom. So I come here, representing this place. I could actually leave now because I'll simply let you know that we have eclipse classes for you guys, and I could leave now. But I thought I'd tell you a little bit about Space Place while I'm here. Oops. So this was the original McLaughlin Planetarium. Don't know if there's any connection. Probably somewhere, right? So for those of you who know this place, it'll bring back memories. For those of you who don't, it's been closed for decades. It was a planetarium, a large permanent domed planetarium, sort of the classical one that you see when you look at books about planetaria. And I think it was closed in '95 or something like that. And Space Place Canada wants to bring one back to Toronto somewhere. We're about the only major, when I say we, I'm not a Torontonian, I'm from Burlington, but speaking of the GTA in general, we're about the only major city our size in the entire world that hasn't got one. So there's been many attempts to try to resurrect the McLaughlin. That didn't work. So then they're moving on to other things. So you may be thinking planetarium, this is the way they used to look. These are examples of older ones. This is sort of the thing that I grew up with. Toronto even had a company that made these things, portable ones. This is the one in Manitoba. This is what happened when the one in Toronto opened up in the late '60s. And we're not looking to get another one of these, because the question that I'm often asked is, well, why the heck would anybody want to come to one of these things? Isn't that kind of old tech? People expect more out of the entertainment venues that they go to, and so on and so forth. So this is not what we're doing, but is sort of the inspiration for where we're headed. A little bit here about the fight to save the planetarium. So we're going beyond that. I know that there's a McCallion here locally, so not looking to do a portable planetarium either. So we've organized ourselves into something called Space Place Canada. We had one fundraising event before COVID blew in. Bob McDonald is on our board and was present at the event. Did a book signing thing and was trying to raise money for it. So we're looking for volunteers. I'm a volunteer. I'm not on the board. You know, have fun doing programming for stuff that's going on online. We were forced after this event, by the way, to then go online. So we've been doing numerous events online, getting speakers from industry. We have industry sponsorships like from MDA, the guys that did the Canada arm, and Pratt and Whitney and so on. We also get in other speakers, whether they're academic or not academic. You know, it's a nice mix of people to sort of keep the interest going for people who are members. And so some of the speakers for this, I go get them and things like that. The guy that runs our outfit, he is comfortable also in the realm of politics. And so he engaged Nanas to go and actually run a survey of Canadians in terms of what they would like to have and is there support for a planetarium and so on. And it would seem that there is support for a planetarium. Actually, I was surprised how high the support levels were for that. Here? Okay, because I'm hearing the whistling. I'm thinking it was maybe having trouble. A lot of whistling for me anyways. We've also got a person who does planetarium design for a living on our board as well. He sketched up something that, you know, it's a fantasy really of what it is that it might go look like. This isn't going to happen, but we're looking at, well, there was some thought also, well, why not use the dome at Ontario Place? Good luck with the politics on that. Right now, what we're looking actually is at Atrium on Bay, right beside the Eaton Center. For those of you that have, you know, been around there, the landlord actually is okay with us going and monkeying with the inside of the building to go and essentially put a dome inside the building. So anyways, if you're interested in more, I'm assuming that these slides or the PDF or something like that can be made available to anybody who wants it. I was only given 5 minutes, so I can't say too much, but there's me. I'll stick around for a few minutes if somebody wants me to give you an email address. That's who I am. That's what I do, besides the HAA and the RANC and the AAVSO. Done.
All right, thank you. Thank you, Tom. Does anybody have any questions for him now, just while I'm switching back to the PowerPoint?
Is the McLaughlin Planetarium torn down and no longer available, or the space that it occupies, is it no longer available?
Sorry. Yeah, the question was, is there still a planetarium at McMaster? You would know better than I would. My understanding is
No, McLaughlin.
Oh, it's gone?
No, it's still operational.
I thought.
They run Wednesday nights.
Yeah.
They run programs Wednesday nights.
Because I think I've seen ads for them on the backside of the HAA newsletter, so I assumed it was still going. Oh,
Sue? The question was about the McCallion.
yeah, McLaughlin shut around 95 or something like that, so it's. Oh, is the land, my understanding is it got sold to somebody to develop as condominiums. Whether it's actually been knocked down, I haven't been at street level beside the ROM in a while, so I don't know whether they've actually finally done it or not. It was part of the museum. I just don't know whether they actually knocked the old McLaughlin down because it sat there for decades. Like they did. Yeah. Okay. Cool.
Doug, were there any other questions for Tom on Zoom? No? We're good? All right. Thank you, Tom, so much for coming tonight
Thank
and
you.
sharing that information with us. It's a very exciting venture and hopefully it'll get off the ground. Planetariums are one of the things that I love, and I'll share a little story about the McLaughlin Planetarium. When I was 4, I came with my parents to Hamilton to visit my aunt and uncle. They took us to the planetarium in Toronto. I wasn't technically old enough to get in. And my uncle lied and said, oh yeah, she's 5. She's just small for her age. And in I went, and it was extremely well behaved. And I remember just having a mind-blowing experience. And that's one of the things that really got me interested in the night sky. So thanks to my uncle who lied to get me into the planetarium when I really wasn't supposed to be there because I wasn't old enough to behave, I guess. Okay, so we're gonna move right along tonight. I want to thank everybody for all the work they did for the December social. We had 56 members out that night, which was awesome. We had more food than we knew what to do with, and all of it was excellent. Thanks to Janice Mannering for organizing it. And I know that she had a whole bunch of people with her who were helping her, a whole bunch of members who just helped with tables and chairs before, put up Christmas lights, took down Christmas lights, dealt with the coffee and tea. There are many of you, and I'll forget half of you. So I'm just saying thank you to everybody. We also had $200 worth of cash donations at the Christmas meeting and 24 pounds of food. And we got a lovely letter back from Hamilton Food Share for our donations. So thank you for being so generous at that time. Library returns, the library is still in storage. I think most things are returned at this point in time. Hopefully we will have it out of storage for in February. For Bob Christmas, the event horizon deadline is Friday, January 26th before midnight. And Bob is looking for interesting articles, pictures you've taken. I know it's been cloudy, but it could be a picture from the past. That will do just fine too. So Friday, January 26th. And John Govro is getting Astro 101 up and running this January. That is our beginner's course, but it's also for seasoned astronomers to pop in and share tidbits and their knowledge with the new people who are interested in the hobby. And for more information, you can email John directly at astro101@amateurastronomy.org. Any questions about the Astro 101 course? Doug, any questions online? The calendar, we had extremely brisk sales in December. There aren't many left, but if you do want another one, they are back there and Marcus has them on the table. If you're on Zoom and you want one, send me an email and we'll see what we can do about getting you one. The 2024 solar eclipse is 86 days away. It is hard to believe that it's that soon, but it is. So I just wanted to bring everybody kind of up to speed on what the club is planning. So first of all, we are not planning any club events on the day of the eclipse. So on Monday, April 8th, there are no club events. That's so that everybody in the club can do whatever they want to do to go and observe the eclipse. So no events on that day. We are working on providing places for members to go to observe the eclipse. The RBG has reached out to us and they are making access free for that day. Their eclipse time is much shorter. So they're not the only place that we're looking at, but they've reached out to us and made the offer and we've done work with them in the past. So that's one place. And we're working on some other places in February. We hope to be able to give you more information about other places that you can go. There's going to be lots of volunteer opportunities coming up, especially in March. We're going to have a clinic and I'll talk more about that in a little bit. BASEF, which is the Bay Area Science and Engineering Fair, has asked us to man a table specifically on the eclipse. And Joanne Salchi is kind of spearheading that, but we are looking for people who would come to the Bay Area Science Fair. It's here in Burlington, to come and spend an hour or so on that Saturday, helping us man the table to give out information about the eclipse to the parents and to the public and to the kids who are involved in the science fair. Steve. Isn't it usually in Burlington? Oh, okay. Sorry. I misspoke. It's at Master. Okay. Thank you for that correction. Yeah. Oh, it's at Mohawk. Now it's at Mohawk. Okay. Thank you. I thought it was in Burlington. That's okay. Now it's at Mohawk. You still have to pay for parking. But if you are interested in helping out for an hour or so at that, and there'll be more information coming about times and all that as BASEF gets themselves organized. And there are a couple of other volunteer opportunities that the club's working on. And again, in February, we'll have more about that. Viewing in Texas. So if you don't want to view here, Doug and I have reserved a campsite in Reynolds Creek Campground, which is outside of Waco, Texas. There are 4 minutes and 13 seconds of total eclipse time of totality. This is a group campsite. There are 3 RV hookups, 30 amps plus water. There are lots of tenting sites. We can take 30 people and 12 vehicles. 4 vehicles have already been spoken for. The cost of the campsite from the Friday before the eclipse to you leave on the Tuesday morning after the eclipse is $270 Canadian total for the many nights. So it's very inexpensive. And for those who are coming, we're going to split the cost. Every camper is responsible for bringing all of their own equipment. They're responsible for getting there. They're responsible for getting home. We're not driving anybody down. We're not taking anybody back. We're not chartering a plane. We're not doing any of that. You're on your own. If you are interested in going to Texas to see this, please send me an email. And at this point in time, I will just reserve you a spot. So I'm not looking for any money or anything like that at this point in time, just kind of a general interest. So right now there are 4 spots that have been taken, but we're opening it up to the clubs. Those of you who have a motorhome might want to drive. Here in Hamilton, we'll get approximately 1 minute and 50 seconds of totality and a 60-40 split of having cloudy skies. So that's why Doug and I decided to go to Texas. And you are welcome to come and join us at that site. Any questions about Texas? Yes, Steve. It flips the other way, 60 clear, 40 cloudy. And the average temperature is about 25 degrees Celsius at the beginning of April. Getting there, you're going to drive through winter to summer. But that's about the split. So we figured it was better to take a little road trip and go to Texas. Any other questions about that? All right. Very exciting. I can't wait to go. Oh, yep. It's actually, the campground itself is not exactly on the center line, but if you want to get in your car and drive to the center line, it's not very far away at all. So we thought this was as close as we could get to be in a place where we could set up our stuff and just hang out. And if we have to drive, we can drive. It's not far from the center line at all. Yeah, Waco's just to the, if I'm looking at the map, it's just a little bit to the east of the center line. Not far. Any other questions? All right. Next announcement that I have. So one of the duties of the chair in the past has been to do all of the programming for the club. So the chair in the past has looked after all of the speakers. They've looked after all of the outreach stuff. They've looked after that stuff. They've been in the Binbrook and all of that, right? So I have a very different take on that. I also have a different amount of time to spend on doing this. So I'm wanting to create a program team. This team would be responsible for creating the HAA program for 2024, 2025. So this year's program is done. We're looking at programming for next year. So one of the things that has to happen is speakers have to be booked for our meetings. We have to look at what workshops or clinics we want to organize through the year, book the space, etc. We want to schedule outreach and public nights. I'm not talking about observing at Binbrook. There is a separate team that looks after Binbrook. One of the members for the Binbrook team is here tonight. So Andrew's here tonight. There's a separate team that does Binbrook. I'm talking about the type of outreach we used to do. So we go to Bayfront Park, we go to McQuestion Park in Hamilton. We'd go down to Niagara. We'd go down to the beachfront near Van Wagner's Beach. All of those days, organizing all of that. In the past, the chair did all of that. And this is not the chair's club. This is our club, right? And it's not just the chair's interests about booking speakers and what you want. It's us together. What do you want to hear about? Do you know of someone? Would you be willing to sit on this committee? This is not a long-term committee. Once you sit on this committee, you're not there for the next 10 years. Okay, that's not the way it's going to work. Maybe in the past, that's not the way it's going to work. So we're looking at putting that together for next year. And I don't want to do it alone, and I'm not going to do it alone. So I'm looking for people who would be willing to sit with me on that committee. We will meet over Zoom. So you don't have to drive anywhere. We'll meet over Zoom. And our first meeting will be in February, because getting speakers is a big process. And if many hands help with that work, then it's going to be easier to do. So if you are interested in working with me to book the programming for next year, so come September, we can say to new members or people who are potentially interested, here's our speakers for the year, here's our outreach night, here's when we need volunteers, here's what's happening at this point in time, so that we can offer a program to our members and hopefully engage new members to come and join us. So you can contact me at Chair. Tonight on the back table, for those of you who are here, if you're interested in working with me, you can put your name and your email on the sheet, and I will get in touch with you, and together we can arrange a meeting date. I haven't picked a meeting date because that will depend on who wants to work with me. So in order to have the best program we have, many minds come up with great ideas and make the work a whole lot easier. All right. Any questions about the program team? Okay, so think about it. You don't have to make a decision tonight. But I am looking at getting started in February. And if you ever do have any suggestions for me about a topic or a speaker that you know of, please let me know. And we can add that into the list. The other thing I'm going to mention briefly is greeters. Last year, we had club members who helped Chris White out at the greeting desk at the back. And tonight, Doug is doing that. Chris is in Woodstock, and I told them don't come. And they said, we're not coming. And I'm saying, good. So I'm looking for people who may be interested in doing 1 month at the greeting table to work with Chris. And if you are interested in doing that, it's easy. You come, you say hi, you hand out the draw ticket, you show them what books are going to be given away tonight. You chit chat them up, you welcome new members, etc. It's a very easy job and lots of fun to do for those who like doing that. Again, you can email me at chair and let me know if you're interested in doing that. And if you're in the room, I have a sheet at the back that you can sign your name and then tell me what month you might like to do it in. February, March, April, May, June. We don't have a lot of months left. So we're looking for cover off 5 months. Okay. All right. Any questions about that? Okay. So our upcoming events, our next monthly meeting is Friday, February 9th, and it will be here, and hopefully we'll have a bigger crowd and the weather will be good. Dr. Christian Sase will be our speaker that night, and he's going to speak on using telescopes to do remote imaging. So iTelescope is the company that he works for, and he's going to explain to us how it works to allow us to sit in our homes and use telescopes around the world to gather images. And they just have added a solar telescope to their arsenal of telescopes, so he's going to talk about that too. On Saturday, March 9th, we are going to hold a telescope clinic and an eclipse outreach here from 1 to 4. Now, it will not be in this room. The church has another big room. This room is booked, so we're in another room, but we're going to hold it here. For those of you that haven't come to a clinic before, the telescope clinic is set up as stations. There are different types of telescopes at each station. People can come in and look at the different telescopes, talk to the people who own them, figure out which ones are good for them or not good for them. I keep moving out of Chris's focus, so I got to move back. And different types of people can also bring telescopes for repair as well. And so we are looking for volunteers who would be willing to come with their telescope to set it up in the afternoon and to answer questions from the public that come. The same time, we're also going to have a station specifically dedicated to the eclipse. So we're hoping people who have solar telescopes will bring those. If it's a nice day, we can set them up outside. And to be able to give glasses, eclipse glasses, and information to the public about the eclipse at that point in time. So if you are interested in volunteering to help us out on Saturday, March 9th, again, you can contact me at chair@amateurastronomy.org. Any questions about the clinic or the workshop? Doug? Oh, yes, you will get eclipse glasses. You guys are number one. Eclipse glasses have been purchased for everybody in the club. You will be getting eclipse glasses. We have eclipse glasses from Space Place tonight, and we are getting 500 pairs of eclipse glasses from McMaster. So we will have lots of eclipse glasses, but you guys are first to get them. And then we'll give the others away. There's a whole bunch of outreach happening. Joanne Selch's doing a whole bunch of outreach with kids over the March break, and Dee as well as helping with that. And a lot of eclipse glasses will go to them as well. Doug, was there a question on Zoom? Okay. All right.
Yeah.
No? Okay. All right, Binbrook, maybe January 20th and maybe Saturday, February 3rd. Maybe. Right now, all of our planned Binbrook dates have been clouded out, including tomorrow. It's not even up there because there's no point. So this 20th and the 3rd. So just watch your email. Hopefully one of them will get a little bit of clear sky. All right. And finally, thank you for going all through those announcements. I have a lot. I seem to have a lot. I think because I'm new in this role, I have a lot of announcements about stuff that's happening. All right, so tonight our guest speakers, I'm very, very excited about this. I have personally worked with both of these gentlemen in doing outreach, and it is a pleasure to work with them, and it's very exciting, and we have a really good time when we work doing outreach together. So tonight we're going to hear from Brett Tatton and Frank Williams, and they're going to talk about the Bluewater Astronomical Society's Kids Astronomy Program. Bluewater is based in Owen Sound, and they have an observatory outside of Wyerton. It's called the E.S. Fox Observatory. And they're going to talk more about the observatory. I'm not going to share that. Frank Williams is the Bluewater Astronomical Society's vice president. He is a retired engineer. Frank has his own Skypod observatory near Allenford, Ontario. He does electronically assisted astronomy, or EAA, solar, planetary, and deep sky astronomy. His interest in the hobby has spanned the decades from the time of film cameras to computerized telescopes and beyond. Brett Tatton was born 1 month before the space satellite Sputnik was launched. If you figure that out, you can figure out how old he is. During his grade school years, the moon race was on, and he was one of those kids impressed by space travel and astronomy. Trips to the McLaughlin Planetarium in the 1970s were instrumental in installing even more interest. However, at home in Acton, he didn't have a local astronomy mentor or even knew of a club he could join. His interest in astronomy didn't wane, and he joined the Bluewater Astronomical Society in 2002. Since joining BAS, he has had many opportunities to expand his knowledge and understanding of the sky and telescopes. Brett is very strongly committed to public outreach in astronomy, of which the BAS's contribution to their partnership with the Bluewater District School Board and the Bluewater Education Foundation is a big part. And thank you, and please give a warm welcome to Brett and Frank.
Okay, I'm going to turn off my video after you guys have seen me. I'm going to try and save bandwidth here. So hello, and now
Brett
I'm going
and
to try.
Frank, can you guys hold on just a minute? I made a boo-boo. I forgot to sign into Zoom on the presentation computer. So you just have to give me a minute. That was my fault. I apologize to everybody for doing that. I thought there was something I needed to do, and I didn't do it.
Okay, I was just going to share my screen with the presentation there, Sue.
Just hang on 1 second, Frank.
Okay.
The people who aren't muted will randomly pop up on the screen.
Doug, do you see me? Can you let me in? You're kidding. Oh, I know why you're kicked out.
Still hear me?
Sorry, because I should have done this.
Could someone just let me know whether or not you can hear?
Hang on. Doug, I'm
We
going
can
to,
hear you, Doug.
Okay, thank you. So,
We can also hear Dave Gaylor.
okay,
all right, Doug, I'm going to do this a different way. So you should be able to get back in.
I'm in.
Just can you read the number out to me? 2.
Night sky.
Got it. Yes. Steve, the answer to your question is yes. Give me a second.
Make sure its microphone is off.
Hang on, guys. We have a really strange looking screen at the front right now. It's reminiscent of the Mandelbrot. I don't know if you're familiar with the early days of fractals, but this is one of the things that they discovered doing fractals.
Doug, tell Frank to share his screen.
Okay, Frank's gonna go share his screen. All right, can you folks see my screen?
Yes.
Yes.
Okay, all right, very good. I'm not gonna put my face on because I'm trying to save bandwidth here because I live rurally and it's not the best. So thank you for the kind introduction. Brett and I will walk you through this this presentation, and also Lorraine Rogers is also present at on the call, and she's also a member and volunteer who helps us out with the kids program. So, and you guys can hear me okay?
It's good.
Okay.
Yep.
Hey, Frank,
Excellent.
am I chiming in as well?
Yeah, so Brett and Lorraine will chime in and correct me if I misspeak. So we're going to get going. So thanks for having us. And we are here to tell you a little bit about one of the outreach activities that we do in our club. And this is a kids astronomy program. And what I'm going to tell you about tonight is I'm going to tell you about the what we do, why we do it, where we do it, the partners that are involved in the stakeholders we have to make it work. I'm going to tell you a little bit about what we've learned from this process, what works, and what we're hoping to do going forward. I'm going to try and keep this to about 35 minutes. And so the first slide I will talk about is where you see the various organizations there. What I'm trying to indicate here is it's not just us at the Bluewater Astronomy Society that's putting this on. We are very, very fortunate in our area to have a number of very strong partners, and I'll speak to those in a moment. Those include the Bluewater Education Foundation, the Bluewater District School Board, our club member volunteers, the Dark Sky Preserve we're lucky to have with the RIC, as well as the Outdoor Education Center. And I'll speak to the stakeholders in a moment. So the Bluewater Education Center is the Outdoor Education Center is the location of where we put on this outreach program. But just so you understand the other people behind it, the Bluewater Outdoor Education Center is owned by the Bluewater Education Foundation, and they are partners with the Bluewater District School Board, as well as ourselves and our volunteers. This facility, it sits on 320 acres near north of Sauble Beach, near Oliphant. And we're very blessed to have this facility. This 320 acres also contains our observatory, the E.S. Fox Observatory. And this was also constructed through the assistance of the Bluewater Education Foundation, as well as a very, very great donation by Spencer Fox of E.S. Fox Construction. And that enabled that observatory, this large roll-off roof observatory, to become operational in 2011. Now, also of great importance is the fact that the Bluewater Outdoor Education Center is also a dark sky preserve, and it's been so one since 2012. And again, so we are blessed with having good stakeholders who are very keen. We have an excellent location, not only the dark sky location, but being part of the Niagara Escarpment UNESCO Biosphere Reserve. And so all of those stakeholders enable us to work with the Bluewater District School Board, who is the primary source of the kids that come to visit. And the Bluewater Outdoor Education Center puts on more than just astronomy. They have a whole realm of programs from canoeing to winter survival skills, and as well as native history and the fur trade. So we're just one small aspect, and we're very pleased to be able to contribute to the Outdoor Education Center, an astronomy program. And I'll tell you a little bit more about what we try to do for the kids. So the kids come up there for an overnight camp out, and we're one of the activities they do at night. Miss anything there, Brett or Lorraine?
You did excellent.
Okay, all right, next slide. So I told you a little bit about where we are, who we are, and the stakeholders we have. Now I want to tell you a little bit about the goals we have for the opportunity that we're handed, right? So our goals are to give kids who come to the Outdoor Education Center, typically they're grade 5 or 6, but we have had high school kids as well, and even university kids, some astronomy experience when they're at a field trip. And currently we do about 2 to 3 or two classes per week. So what we try and do is, given the limited time we have with them, which is about 90 minutes with the kids, we want to impart to them a skill that they can take home and use at their leisure. And the skill we pick is using a planetarium app to find objects in the night sky. And that's because everybody has access to cell phones or tablets, and most people have access to binoculars. And so with free apps, free planetarium apps, which weren't available when I was starting out, they have the ability to find things in the night sky and answer their questions long after they leave our program. We also want to give them an opportunity to look through telescopes at objects, because a lot of these kids have never actually looked through a telescope before in their life. So it's literally an eye-opener for them. We also want to supplement the STEM education that the kids get and foster that sense of wonder for the night sky that we all get when we look through an eyepiece, and provide an astronomy resource for kids, teachers, and parents should they wish to pursue astronomy more. But most importantly in this process is that we have to keep this interactive and fun, because too many times we've all experienced the person standing at the front of the classroom, the talking head, and it's boring. And that's not what we want to do. None of us are teachers in our volunteers currently, but that's the goals that we have for the limited time we have with the kids. The next slide you should see is, I want to give you an overview of the facility where we do our outreach. And here we have the Bluewater Outdoor Education Center. You'll notice on the right-hand side is the Bruce Power Environmental Learning Classrooms. So we're fortunate to have classrooms on site with our observatory. To the left is, oops, let's go back up here. Okay, and you can notice circled in red is our observatory. And between the classrooms and the observatory, the space between those two we use for our planet walk, and Brett will talk more about that later on. At the bottom of the screen, you can see a drone shot of our observatory, the ES Fox Observatory, with the roof partially open. And to the right of that is our largest telescope, a 28-inch Webster that we can use. So that's the blessing that we have as a dark sky location, access to classrooms, access to an observatory, and access to kids.
Can I just chime in there, Frank?
Go ahead, Brett.
Yeah, the building to the left of the poster says ES Fox is the dining area and residence for the overnight stays. And the groups generally come for two nights, 3 days. That's why we have 2 groups per week. And the site is actually on both sides of the road. Up to the left is a lake, and there's camping, and down to below the screen where it cuts off on the picture, there is another lake, and there's these field areas which local farmer kind of keeps the weeds down by taking hay every year, so that's why it's open.
Yeah, so if you're not familiar with our, come visit us sometime if you want. We've got, as I said, in the other previous slide, that the dark sky readings are typically 21.5, and in the previous slide I showed, we have you can see the northern lights that we can see from our observatory. So if you're in the area, get in touch with us and stop by for a visit, because it's good dark skies. Okay, next slide I want to talk to you about is, okay, we've got facilities, we've got kids, we've got partners. So I told you what we're going to try and do. So what do we actually do? Well, we break our program of basically 90 minutes with the kids into 3 segments. The first I'm going to talk about is, what do we do in the classroom? So we get the kids show up in our classroom, and the first thing we do is we do introductions, and then we do an icebreaker to get their attention. And the icebreaker, the first thing we use the old good cop, bad cop routine. First thing I tell them is, we're going to start this off with a test. And of course, you get the rolling of eyes and groans, but it grabs their attention. And it is a little short quiz with funny questions and answers, and it gets them hooked. So first thing you do is grab their attention. Then once we get through the icebreaker quiz, and I'll show you an example of one of the icebreaker questions in a moment. Then we basically make sure everybody understands, has the same understanding of where they are in the universe. We do a short video, 4-minute video from National Geographic on the solar system. So they know exactly where they fit in the galaxy. And this ties into our planet walk later on. Then at that point in time, we hand out iPads. Typically, we have about kids 2 or 3 to an iPad. And we give them a brief instruction on how to use a planetarium app. And because I know some kids have already seen those, others haven't. And the idea is we also use the concept of a star chart that we're familiar with, but these days and age with kids and tablets and phones, that's pretty old technology. So after a little bit of brief introduction on how to use it, and we tell them why we're going to teach them how to use it, and they're pretty hungry to play with the iPads at this point in time, we then say, right, now you seem to know what you're doing, we're going to have another test. And of course, you get more eye rolling and more groans, but by this time, they're onto us. And they know that this test is not going to be a terrifying thing. And so we have a number of fun exercises where we ask the kids to do something with the planetarium app, which we use Sky Safari and Sky Portal is the free version, so that they become accustomed to locating information or locating things in the night sky using a planetarium app. And using these quiz questions, we can sneak in all their kinds of astronomy information, and they enjoy it because it's interactive. We ask the kids to, as they're going through, to put up their hand when they have an answer. And this way we can gauge the class and find out who's got an answer and who may need some little assistance. And then we use our volunteers and parents and teachers to assist the kids so they are all successful in finding what we want them to find. It sometimes gets competitive. So who puts up their hand first, right? And a little competition isn't a bad thing either. So after we do a number of fun exercises, we're convinced that they can use the planetarium app reasonably well. We will show them how to use the compass feature and point the iPad to the object they found, right? And then following that, they're ready to go to the observatory. Now, the observatory may be clouded out. So if we know that we're not going to be able to see much, we'll also throw in a 5-minute slideshow of objects in the night sky that they could see that our local astronomers have taken pictures of. You know, not off the web, but these are actual people in our area who've taken pictures. So to give them a flavor of what they could see if the sky was clear. And then at that point in time, which is typically we'd have no more than about 45 minutes of their attention span, sometimes less. But so now they have the skills they have and to navigate the night sky with some assistance. So we take the iPads, put them in night mode, and take them to the observatory. Lorraine or Brett, anything else?
I could chime in there, Frank?
Yeah, go ahead.
Well, we were just lucky to have 12 iPads because the Board of Education had them on site. And I don't think anybody really put them to use for a number of years. They're not exactly new. But because of the fact that we've employed them extensively for over a year now, they're now known to the site people as the astronomy iPads. And 12 just seems to be about the right number for a class group. If it's a really big group, we might have to put 3 students on one iPad, but it's generally teams of 2.
Okay, thanks for that, Brett. Okay, so the next slide, I've got an example of one of our icebreaker questions. And you can see that we introduced the concept of constellations and asterisms in a quick quiz question. And you notice there's only three potential answers. One of them is a funny one that they'd be relate to, and other two are possible, right? So the icebreaker enables us to grab their attention, have a little bit of humor, keep it interactive, and slide some concepts across them to them. And here's a sample of the video that we use from National Geographic. It's short, to the point. It introduces the concept of our place in the solar system and the planets, and it ties quite well. And then we can reinforce this information when we move on to the planet walk, moving from the classroom phase to the observatory phase. The next slide is on a sample of one of the exercises we do with the iPads to help the kids. In this case, it's the Big Dipper asterism. So again, we can reinforce the concept of asterism and constellations. When we can introduce the concept of how the night sky is broken into pieces so we can find our way around via the official constellations. And you notice that there's 2 silly answers to keep it interesting for the kids, and 3 potential answers that it could be. So the kids, with the use of the hint that we give them and the initial instruction, and through the use of our volunteers and teachers, we can get them to find information on something they're probably already aware of, the Big Dipper. So we have up to 10 questions. Typically, we don't get through more than 4 or 5 until we're satisfied the kids have the skill that we want. And it can be quite entertaining because the kids get engaged and can be yelling out answers and pounding on the desk. So it can be quite entertaining.
Hey, Frank.
Yes.
The thing the fine tuning that happened in the last month or so was, in order to tell how well they were doing with the question, we told them, when your team has the answer, put up your hand, and you can glance around the room and see some of the hands go up pretty quickly. Others forget to put their hands up and you have to remind them. And then there's the ones that haven't got their hand up, and the volunteers can circle around and look over their shoulder and see what's causing them difficulty.
Okay. Thanks,
it's generally
Brett.
something pretty simple, and they are pretty, once they learn that lesson, that's the last time they have concern about using the iPad, using the Sky Safari to do that particular task.
Okay. Thanks, Brett. Okay. So now we're going to talk about moving from the classroom portion to the actual in the field portion. We'll talk about the planet walk separately in a bit. So the next thing we do is we get down to the once we're down the observatory, if it's a clear night, which we want to do as quickly as we can to maximize the kids' use of being able to see the sky. We get the iPads out again, and we repeat the exercise and have them find the Big Dipper and the Little Dipper using the iPad compass feature. So we're just reinforcing the same skill that they've already learned. We then branch out to other constellations. We have them find 1 or 2 other constellations, such as Cassiopeia, which is an easy W shape, or Orion. Then we have the kids find a planet or 2. Jupiter is a great one. And then lastly, we have them locate good visual objects, such as the double cluster, which we also cover in the classroom in our quiz questions, the Pleiades, or if it's clear enough, the Andromeda Galaxy. With that, we've now taught them a skill, we've reinforced it, and they've actually put it to use for real in the field. So at that point, because we've only got about 45 minutes with them in the field. So what we do at this point is we collect the iPads and we do an observatory tour, and we open the roof. Actually, one of the kids, we pick a kid who has a birthday closest to the time we have. We get them to push the button to open the roof. Answer questions about the telescope. We may be able to sneak in some information on our dark sky preserve. And then we break the kids into groups. We have previously set up, and I'll show you a picture of this later on, the observatory with different instruments set up for different objects and tracking, so that we can quickly break the kids into groups and they can see some of the same objects they just found with the iPads, like a planet Jupiter, right? Or the Pleiades, right? So we try and have enough instruments set up to give them a variety of objects to see in the night sky. It would be clusters, nebula, and binocular stations. So, and then typically after about 45 minutes at the observatory, unfortunately, kids' attention span tends to wane. We watch that, work with the teachers and parents to gauge where they are. And when it becomes time and they're losing interest or getting cold, what we do then is we get everybody back together. We wrap it up with a bedtime story of Andromeda and Perseus and the Medusa, because they know some of the mythology already. So we tie it all together. They can point at the constellation Cassiopeia above if we've gone there, and we do a summary of what they've learned and what resources are available to them, and then we send them on their way. Miss anything there, Brett or Lorraine?
Nope, that was great.
Okay.
I might
So-
have some things to say about the picture slide though, before you start. Oh, nope, move on. Next one.
Okay.
Yeah.
All right. Did you want to?
This was the open house weekend where the outdoor ed center invite the public. So I just went down to the observatory and tried to make it look interesting. I got a Dobsonian set up and some slides there on the table that one of our members, Keith, produced from some astro images of his, which are wonderful. And you can see all the posters on the wall. And Frank, I just wanted to mention a few things there. You can see we've got our 3 piers, of course.
Yeah, and as Brett mentioned, inside the observatory, this is obviously with the roof closed. We've got 3
It was a
piers.
very rainy day.
Yeah, which is quite common. And as I said before, we try and set up different instruments on each pier so to maximize the opportunity for kids to see. And as Brett also pointed out, you can see Dobsonian telescopes will often take a Dobsonian outside. And what you can't see here is we always try and set up a binocular station on a parallelogram mount, because binoculars, as you know, are an entry point to astronomy that many kids have access to. And also looking through with 2 eyes is easier than with 1. And on a parallelogram mount, it compensates for kids' heights, and the kids really enjoy it. So it's another way that you can ensure that the skills that or what they see at this program, they can apply at home later on.
And
Well,
they want
also,
they want to look through a telescope no matter what. The telescope set up in the doorway there is aimed at the top of the internet tower at a little dish, so they could look through the telescope and actually see something. They don't care. They just want to look through a telescope.
And that's a good point. And the other thing we'll do, if we have enough volunteers, we'll also set up an electronically assisted astronomy rig, and that enables kids to see in color. And I'll have a slide on that later on. So that's what we try and set up in advance at the observatory. Now, so here's some sample EAA images. When we do EAA for the kids as one of the stations, I've been using the C-Star. There's probably some better solutions out there, and we've also tried ASI Air with DSLR. But the beauty of this is you can get an integration of less than 15 minutes and see color, and you can then allow multiple kids to see at the same time color, and they're also fascinated by the technology. And you can point out, yes, you're controlling this telescope with an iPad, just like you were operating the iPad planetarium software, because the planetarium software is very similar for Sky Safari and this particular one. So we find that works. Now, if and quite often it is cloudy, what do we do then? Okay, we do a planet walk to the observatory, and Brett will speak to that in the next slide. But even if there's clouds, there may still be enough stars or constellation or bright planet to use the iPads to find. And so we can still possibly reinforce that skill. We still do the pick a kid and open the roof and do the observatory tour. But because, as Brett has pointed out, kids really have a hunger to look through a telescope. what we do in that case is Brett has built a shadow box of Saturn, which is illuminated. And we set that up in advance, knowing that we're going to likely be clouded out. And then the kids can still look through a telescope at a simulated, they can still look through a telescope. It's not the real Saturn, but it's a simulated view. And it's, so it still satisfies that thing that we're trying to do, is get them to look through a telescope. And then, of course, we still do the bedtime story of Andromeda and wrap up with a summary and resources that are available. And as you see, everything we're trying to do here, we're trying to keep it interactive and fun for the kids, right? It's no good if it's not fun. We're not going to maintain their interest. And besides, if I'm not having fun, why am I there, right? So, any case. So now Brett's going to tell us about the solar system walk that we do between the Bruce Power Environmental Classrooms and the observatory. Brett?
Thank you, Frank. I just wanted to reiterate that I think at the end of every one of these evenings, we look back and go, wow, that was a bit crazy, but we had some fun, and the kids certainly do. That time it takes to get between the classroom session and the observatory is about, if you really just got out the stopwatch, it's about 2 minutes. And the thing is that these children are, they've been there for one night, and they're finished up their second day. They're more than halfway through their stay, but they're still pretty wound up, and they know that they're going to go down and have an adventure at the bottom of the hill. They're pretty wound up, some of them. And the trip down the hill turns into a bit of a chaotic situation sometimes. Depends on how the teacher handles the group. And in any case, it felt to me that we were wasting that few minutes walking down the hill, whether we could use it or not. And in the past, we discussed things like planet walks with different people, and tried one at one point in the past. It just dawned on me that we could come up with a scale for the solar system and make it fit in so that the sun was at the schoolhouse and Neptune was someplace close to the observatory. And the scale turned out to be a 5 centimeter sun, which gives you a 0.5 centimeter Jupiter, which is the size of a pea. And 150 some odd steps later, you're billions of kilometers away at Neptune. But to keep it moving, we don't have any, typically don't have any artifacts. There's no models of the planets. It's just an imagination thing. And it's not taking a lot of time. So we're only going to take 2 steps to get to Mercury, for instance. Then I get the one fact about at that point, move on to Venus and Earth. And the question at Earth is, we just did a trip to Earth in 6 steps in so many seconds. How long does it take light to actually go to get to Earth? And it's surprising how many of them know that that the light travel time from the sun to Earth is 8 minutes. It's always surprises us that there's a number of students at that grade 6 age that are quite interested in astronomy and the universe. And this could happen. The group could be later in the year when they might have covered some curriculum, but we also get students at the beginning of the year where it's possible they haven't had any curriculum. So by the time we made our way past all the planets out to Neptune, then we just try to give them a moment's pause to realize how distant that is in actual fact by comparing the travel time of the Voyager 2 spacecraft, which is the only one that visited Neptune, was 12 years in space between leaving Earth and arriving. And then if you were going to travel on to the next star, that poor spaceship is going to be lonely for the next 70,000 years. And then at that juncture, we're looking at the observatory, and we would take the time to tell them what's going to happen next, which could be the iPad activity, et cetera, depending on the evening. So the planet walk, the solar system walk, we don't want it to take up a lot of time. It's just a way to structure the travel time between the schoolhouse and the observatory. And it seems to have worked. We've had a chance to try it 2 or 3 times now.
Okay. All right. Thanks, Brett. So I told you, who we are, our partners, where we are, what our goals are, and how we do, and it's not the only way to do it, but it's what we're currently doing. So what's the feedback? Well, we've had very, very positive feedback on the program so far. In the last couple years, we've been running it like this. So, for example, the teachers are very happy because the kids are engaged, and the kids may not have had any sleep the night before because they've been having so much fun spending the night with their friends in the dormitory, right? So the fact that teachers are amazed that we can actually hold their attention when they haven't had any sleep, and they really like the fact that it's interactive and fun. The parents, the chaperones that are there, also seem to really, really enjoy it and thank us for it. And they're feverishly downloading Sky Portal onto their phone. And some of the parents are disappointed they have to take the kids back to the dormitory because they'd much rather spend the time at the observatory looking through the telescope. So they really like it universally. So the parents are very, very enthusiastic and thankful for the facility we have and the program we deliver. The kids, one of the quotes, this was the best space day ever, right? That was one of my favorite quotes you've heard. And having the kids look through and see the rings of Saturn or Jupiter for the first time, you know, they actually buzz with excitement. We all know what that's like, but to see that repeatedly with kids who have never looked through a telescope before, the reward there for us volunteers is just huge, right? So we get a lot out of that. And we get, like, kids looking through binoculars will come up to me and give me fist bumps and high fives because they're just so excited to be able to look through binoculars. And they say, I've got binoculars at home, right? So they're pretty excited that they can actually find things in the night sky using a planetarium app, see it with their naked eye, and then see it through binoculars or telescope. It really, really, it gets them thrilled. And even in the classroom portion, the enthusiasm in the classroom for our silly quiz questions and interactive exercises, you know, the kids are thumping the table and yelling out answers. So they really seem to enjoy it. Sometimes it gets kind of unruly. But perhaps the best compliment we've had recently was the compliment, this is better than a video game, stated by a boy at the observatory. So that's pretty high praise. So we seem to be getting positive feedback. It's working with the parents, the teachers, the chaperones, and most importantly, the kids are having fun. And we know they're learning things because when I say, okay, when we talk about the bedtime story, and I ask them, and where would the constellation Cassiopeia be? And they pretty universally point right at the W. And so, you know, you managed to sneak in a little knowledge, and they had fun at the same time.
Frank,
So
I see two questions pop up. Paul asked about what we do waiting for it to get dark in May and June. And what we found is that we really can't do the program after the time change almost. We only get maybe a couple of weeks after we go to daylight savings time where it's even dark by the time the kids are like, it just doesn't work at that late in the year. But in the fall, we're able to take advantage of the dark during the time frame because they want to start at 7. And in the springtime, that's still too early for dark. So, and Joanne also asked about running it in the summer. Well, we don't have to worry about bedtime as much, but the students aren't being brought to us at that point. So we'd have to organize an event where they came to us. Or alternatively, we'd have to take our program on the road, and we haven't tried that yet.
Okay. And the other option is we do have solar telescopes, and so we'll look at the opportunities to use those more when it's not dark enough at night. But
or a view of the moon, which is visible during daytime.
Yeah, so there are some enhancements, but it is more challenging. Okay, so now I want to tell you a little bit, so you know, what we learned. I mean, we're trying to impart knowledge to the kids, but you know, we're learning too. So what have we learned? Well, we learned the paper and pen exercises are boring, time consuming, and everybody hates sharpening pencils. So if you can do it all electronically, you can set up and take down much faster. As I said, using the good cop, bad cop, grabbing their attention by telling them you're going to start with a test. You know, it grabs their attention. It's funny, but you know, it does hook them. and the interactive use of tablets, and the fun quizzes, interactive funny questions and answers tends to keep the kids' attention. So as if you keep it interactive and you keep it fun, then you can keep the kids interested, engaged, and learning. As Brett already mentioned, the Planet Walk can slow kids down. Well, this is important because they will tend to run to the observatory. But with the Planet Walk and holding them at various planet stations and holding up a picture of a planet with the iPad in the dark, it will prevent them from running as much, and that's a safety issue, right? So as I mentioned, we've found that the attention span for the kids that we get typically is about 45 minutes, no more than that in the classroom, and about 45 minutes at the observatory. But every school, every class is different, and you have to be able to tailor the experience to gauge where the kids are. Some kids need more assistance with using an app, some need less. You know, in some cases, we've had cloudy nights and we've had to invent on the fly more questions to keep the kids engaged because they were flying through questions and exercises quickly. So you have to, every class is different, every kid is different, and you have to try and adjust as you go with the parents and teachers and chaperones to try and give the kids the best experience with the limited time you have. The bedtime story is a good way to wrap things up and tie it to mythology. And you can also talk about other mythologies and other constellations that other cultures have, like our native peoples. So that seems to work to wrap things up. We have found that the planetarium app skills that you teach them in the classroom, when you use them outside, it really reinforces it, and it gives them a skill they can take home, and they all have access to basically phones and tablets, so they can take that astronomy knowledge and put it to use long after they leave us. And some kids have used a planetarium app, but they really don't know what they can do with it. For those kids that have never used a planetarium app, it's a real eye opener, and the parents are really engaged too on learning to use a planetarium app. A variety of telescopes is important to maximize the amount of objects that you can show the kids. Always include binoculars, because that's the entry point for a lot of people because it's accessible. And as I mentioned, parallelograms are really good. And when you're using iPads in the field, make sure you put them in night mode, because iPads are really, really bright. When you get like 12 of them out there, it's blinding. So we found that. Anything else, Brett or Lorraine, you want to mention that we've learned?
No, that's good.
Okay.
I think you've covered it very well.
Okay.
Indeed.
Okay, so now I'll tell you, that's where the program is. That's what we learned. What are we planning to do, or what ideas do we have to make it even better going forward? Well, obviously, we need to train more volunteers. The more volunteers you've got, the more classes you can do. We want to improve on our dark sky preserve information into the program. Electronically assisted astronomy is growing leaps and bounds, and it has great potential. Now, obviously we want them to look through an eyepiece first, but EAA gives you the ability to show color and long exposure images. So I want to use more of that and see how we can tweak that to get the most out of it for kids. Plate solving, for example, using StarSense Explorer phone app, where the phone takes a picture of the night sky and then does plate solving and helps you point a telescope. We've got that on the Webster, but that's an opportunity we think that we can put on more Dobsonian. So kids can actually use the skill of using a planetarium app to actually point a telescope themselves. So that's an opportunity we'll pursue. The Sky Safari can also interface with some of our telescope mounts, so you can directly show the kids, not only can you point the iPad at the sky to find out where it is, you can actually tell it to point the telescope and then look in the eyepiece and see the object. So we'd like to pursue that a bit more as well. More shadow box planets would be useful because we get a lot of cloudy nights, or even a permanent mounted stations for a planet walk. that you could actually use during the daytime with groups as well. And we want to move from delivering our short display of what you can see in the night sky in the classroom to actually doing that at the observatory. So because that would flow better for us, but we're not quite there yet. So those are some of the future enhancements that we're hoping to do to make the program even more successful and with kids. And we'd love to hear if you've got some ideas from your outreach experience on ways that we can enhance our program as well. So if you have ideas, we'd love to hear some of your ideas. So with that, that's my 40 minutes. Brett and Lorraine, is there anything that we've missed before we take questions?
Nope, that pretty much covers it as far as I can recall.
Okay, so if there's, then we'll take questions at this point in time.
Frank and Brett. Thank you very much. Frank, can you stop sharing your screen, please?
Yes, I will do that right now. Okay, it should be stopped now.
All right, there we go. Okay.
Joanne asked an age rate related question. So younger than 10. The youngest groups we've had brought to us are grade 5 and grade 6 splits. So in our area, there's a lot of territory, and the schools have aren't very big. It's a geography issue. So there's often there's split classes, but the youngest ones we've had are grade 5. So I'm going to say they're older than 10 years old. So doing this kind of thing for 10-year-olds, you might not want to rely on the iPads as much, I'm guessing. But you don't know, okay? Good question.
Doug, are there any other questions in the chat on Zoom?
Not at this time, but unless someone in Zoom wants to turn their mic on and ask their question directly, that would be fine too.
If there isn't, I'm going to go to the room. Are there any questions in the room? I have a question. Is there any aspect of your children's program that you have found transfers into doing outreach with adults?
Yes, I mean, the adults, of course, the whole idea of a planetarium, that translates to adults as well, very well. So
I personally have gotten better at setting up Skywatcher and Celestron go-tos as fast as possible with the least number of objects to point at it, and not getting really freaked out because it's not dark out and all I got is Jupiter. What happens when the real stars come out? And I'm going, hey, I can handle this.
Because I'm going to use an example that I did with you guys when we were looking at the Perseids in the summertime. And in the observatory, Frank had his ASI Air, and he was able to show the adults full color pictures. And then he would send them out to the field, to the telescopes that were out in the field of varying sizes and types. And they would look through the telescopes with the actual object in the sky and then compare the two. And we could talk about color differences, et cetera, et cetera. So again, even though the kids are really engaged with the technology, adults were really engaged too, to see it in full color and then come and look at it with their own eyes through the telescope. And it was kind of a nice way to do outreach by harnessing that part of technology, which is something we haven't really done a lot here, but maybe it's something that we should think about in the future. So I'm going to make the last call for questions. Doug?
There is one more on Zoom. Paul Gross asked if you any way. I'm sorry. I'm hearing myself in two spots. Paul, could you turn your mic on and ask your own question, please?
Good evening. The question is, do you tell the students what was walking the earth when they look at an object that is, say, 15 million light years away? My grandchildren, I show them stuff that's relatively close to us, even though it might be 5 or 15 million years old, the light. They didn't really care until I told them, well, when that light left that object, mastodons were walking the earth. And
Got their attention. Dinosaurs work, Paul.
that turned them on to the stars. I was wondering if you did that.
It seems that they're pretty, the level of anticipation generally seems to be high. For some of the students in the classes, it's higher than others, but in general, we don't get a classroom group that isn't already excited. I think they're at a good age for that. They're at a good age to be away from their parents and in a group at that age. Younger students wouldn't be able to be away on a group situation like that. And older ones might not behave so well, although the high school students we had recently were quite good. So I was trying to impart the feeling of how far things were away by using the scale model. And you don't know if you quite get there or not, right?
Yeah.
And the time it takes light to travel. The walk to Mercury takes 2 steps. And I didn't bother to tell them that it takes 3 minutes for light to travel from the sun to Mercury because all of a sudden you're into too many details.
Right.
But we can mention to them that Jupiter, the light from Jupiter took 45 minutes to arrive here. But
Right.
stars, it takes years for the light to arrive. They're that much further away. Is that what you're getting at, maybe?
Thank you very much.
Are there any other questions? Okay. The woman in the background that you heard there was Lorraine Rogers, and I wasn't aware that she was going to be part of the presentation tonight, but she has also been instrumental in putting together this program. So a big thank you to Lorraine for coming tonight as well. And a thank you to Brett and to Frank for sharing their experience with us. And I know that there are things they talked about that I think we here at the HAA could weave into our own outreach program. So thank you very much, guys, for joining us. And we appreciate your time. So thank you. We are going to...
We enjoyed having the opportunity to tell you about it. And we look forward, if you got any other ideas, send them our way.
We definitely will. I know Joanne's brain is thinking as she sits at home about what she's heard. We're going to take a quick, 8-minute break, and we'll reconvene at 9 o'clock, and Matthew will share this guy this month with us at that point in time. So we'll take a quick break and we'll be back.
People in Zoom,
Happens when you go. People. All right, so we're going to turn. Oh, we have to do door prizes, don't we? We have to do door prizes. Thank you, Chris. Doug, are there door prizes here for people who are not here tonight?
Unfortunately, I was too busy to make door prize tickets for each person on Zoom because we have more people on Zoom than we actually have in the meeting.
All right.
So
Robert,
sorry, folks.
pull a ticket. All right, ticket number. Last 3 numbers, 839. 839. Oh, it's Marcus at the back. Marcus, you have your choice on Chasing New Horizons, astrophotography, and your guide to the sky. All are very interesting. All right, Dave, you pull the next one. The next one tonight.
228.
228. 228. Going once, going.
Yes.
Is that right? That's upside down. 838. 838. Oh, Bob, there you go. Off you go. All right, before you go, pick the last one. He's not looking. All right, I'm going to look at it right side up this time. 844. 844, and it's Doug. Excellent. Congratulations, guys. 3 good choices. In fact, I got stuck reading the Mars one or the Pluto one while I was getting the presentation ready and thought, okay, I have to stop reading this. I got to put it down. Okay, so now I can turn this over to Matthew Mannering, who is going to share with us the sky this month.
Can I share screen now? Whoa,
Oh, wait, 2 seconds.
you got infinity going on there.
I know. Infinity has stopped. You can share.
Okay. Screen. Share. How do I get rid of that thing at the top? The menu at the top.
You can't. I have to.
That little menu there with remote
Oh,
control.
you have to get rid of that one yourself.
How do you do that? I forget. It's been years. Gosh, it's been a year. Is it more? And then
You should be able to click on your view options, Matt, at the top.
I got it. There, I think I got it. All right. Are we ready to go?
You're ready.
You see pictures of Uranus and Neptune there?
Yes, we're good to go.
Awesome. All right, so welcome to the sky this month for January 24. We had intended to be there tonight, but the weather had other plans. If I start coughing partway through and have to stop for a drink, you'll have to excuse me. I'm still getting over a rather nasty cold or virus. So let's give this a go. So what's in the news lately? Well, a few things that are interesting. For instance, they've just reprocessed images from Voyager that show that Neptune and Uranus are actually almost the same color. Now, forever and ever, we've been told that Neptune is much bluer and Uranus is kind of a greeny, light green color. And the reason that they supersaturated colors on Neptune originally was to bring out these dark storms that were in the atmosphere, whereas with Uranus, there's just nothing there to see. So they really wanted to bring that out. And that color, use of color, has stuck with us for all this time. If you look at the lower 2 images of Uranus and Neptune, you can see that Neptune is only slightly bluer, and even though it hasn't been super saturated with color, you can still see that there are some storms there going on in the upper atmosphere. So personally, I have a slight issue with this in that when I look at them through binoculars or my telescope, I do see Neptune as substantially bluer than Uranus, and I see Uranus as a pale green color. So don't know if that's atmospherics here or, looking through the atmosphere. I don't know what it is, but my own impression of these 2 planets is it's not near as blue as the blue in the top right corner, but it's not anywhere near as pale as the bottom right corner when I look at Neptune. And Uranus usually looks somewhat greeny. So let's see if I can get this slide thing to work here. Now my slide show's not working. Why is that? Okay, my slides won't move. Let's try that. Here we go. Okay, next slide. So Uranus is really interesting in that it actually spins with its axis pointing almost directly at us. So whereas our axis is tilted at 23 degrees to the ecliptic, the axis of Uranus is like 98 degrees to the ecliptic. So when we see it over a period of 84 years for one orbit of Uranus, we actually see first one pole, and about 20 years later, we're looking at it from the side and we're watching it from pole to pole. So we see the whole from the top to the bottom as it spins. And then in 20 odd years later, we see the other pole for a while, and then we see the other side that comes around. We get to see from the pole to pole again, and then it starts back to where it was. So over a period of many years, we get to see it in different aspects. Now, one of the interesting things that they found is that the color of Uranus changes from our perspective depending on the season. So when one of the poles is pointing at us, the poles, there's less methane and there's more ice crystals. And this tends to make it look very whitish and bland. When we see it sort of side on, and we can see the equatorial region as part of it, there's more methane in that area, and the way light is absorbed and reflected, it looks bluer. So if I can make this work, this is, you can see the start year over here is 1900. It's actually going to simulate Uranus spinning over many, many years. And you can actually watch it as, on the right side especially, you can actually see it spinning from pole to pole over that many, many years. And you can see when it's side on to us, that it's much bluer because the methane is at the equator and the mid-latitudes and not at the poles. So depending on when you actually happened to observe Uranus over the years, you may have seen it bluer than what we see it now, just to confuse things. This is a picture just released by Webb, the Webb telescope. And as you can see from here, it's a great image because Uranus is still not exactly pole on to us. So we can see the equatorial region. We can see some storms going on there in the blue area. And we can see the very white pole that's almost pointing at us. You can see moons going around Uranus. And you can see the very, very, very faint rings that normally you would never see through a telescope or anything like that. So Webb regularly posts with its newest images, and there's always something interesting that's just happened to tie in with what I was talking about, and it's current. Another really cool probe that's out there is the Juno probe, which is at Jupiter and has been now for quite a long time. Part of the probe, the Juno probe, is the Juno cam, and the idea of that cam was to last maybe about 15 orbits, and it would then send back full high-res color images. And the idea was to allow amateurs to do the processing of the images because, quite frankly, NASA doesn't have the people or the time, and actually probably the amateurs are better at it. So the Juno cam has lasted way longer than they expected. We're closing in, I think, on 60 orbits. And it is only just starting to degrade now. And the reason it's degrading is because every time it goes through an orbit, it's going through massive radiation belts that surround Jupiter. And they are much, much, much more intense radiation belts than what we have around the Earth. So every time you send electronics through these belts, they get fried. So everything is hardened, of course, electronically to resist that, but do have limited number of windows where the electronics will still work. What you can see here are two images of Io, the innermost of the Galilean moons. It's the moon that spews sulfur from hundreds of volcanoes that are scattered over the surface. And the surface is constantly being remade, but I have never seen images as wonderful as these. So the one on the left, I believe, is from October, and the one on the right was just from a few weeks ago. So again, the Juno probe at Jupiter, it's worth going to that website and looking at some of the images that are there. And I believe you can probably download some of the raw data and play with it yourself if you're so inclined. These are just fabulous views of Io, like we've never seen them. On the missions that may someday happen front, Artemis has been delayed, as you know. Our first manned mission, which was to actually just go to the moon and circle around and come back, kind of like Apollo 8 did back in the day. It's been delayed basically a whole year, which now pushes landing on the moon into 2026. So don't be surprised if that goes to 2027. Unfortunately, delays at NASA seem to be synonymous these days and have been for many years. So I know they have to make things safe, but gee, They were much faster in the 60s when they did this stuff. The latest delays have to do with damage to the tower. It was more than they expected from the previous launch. The heat shield, although it didn't fail on the last mission that was uncrewed that came back, apparently there must have been more damage than they anticipated, so they're looking into that. And also it sounds like they're having problems with the different streams of materials and modules that they're building and trying to get everything to be ready at the right time. I guess that's causing issues as well. When you have so many contractors, probably that doesn't help. So the eclipse coming in April is obviously a hot topic, and I'm just going to mention a little bit about this now. So on the web, there's a fantastic website called Time and Date. In fact, Steve Germain talks about it in the Event Horizon, I believe, this month a little bit on using this website. There's tons of stuff that you can find out from this website, but one of the cool things is it covers all the upcoming eclipses and really spends a lot of time looking at the next one, the next big one that's coming. So if you go under the heading there, Sun, Moon, and Space, I think it is this one. If you look down, you'll see the April 2024 eclipse. You click on there, and a whole bunch of stuff comes up. The main point is there's an interactive map, and you can click on the map and say, what's it going to be like if I stand right there? So the first spot I chose is McQuestion Park in Hamilton. And this chart of information here tells you what you need to know. For instance, it tells you that for McQuestion Park, that duration of totality is going to be 2 minutes, 8 seconds. If you're in Dundas, for instance, it's less than 2 minutes. It's quite a bit less than 2 minutes. So you can get 2 minutes and 8 seconds from McQuestion Park. It tells you when partial begins. It tells you when you're at maximum. It tells you when the whole eclipse thing ends. And it tells you the average cloud cover, which is basically means that 2/3 of the time you're going to be clouded out since 2000. If you want, part of our original plan was actually to drive to Fort Erie. There's Buffalo there, Fort Erie. At the end of the QEW, you can go down to the waterfront, and there's all kinds of parks there. You can, pretty much with a solar eclipse, you can be anywhere and observe it. There are some nice open spaces there. Now, this dotted red line that's running up to the right under the word Buffalo, that's the center line of the eclipse. And so you're really very close to the center line, and you will get 3 minutes and 46 seconds there. So that's substantially longer than the 2 minutes and 8 seconds. And you say, what's an extra minute and 38 seconds? Well, if you watch an eclipse, it'll be the fastest 2, 3, or 4 minutes of your life. It's over before you can even believe it. So the longer you have to look at it, the better. And if you have some sort of weird sort of mixed cloud situation, if you're in a spot where you get almost 4 minutes and it's partly cloudy, you might have a better chance of seeing at least part of totality. The cloud cover there is a little worse than in Hamilton, but it's really insignificant. And here's a spot many of you probably haven't thought of. You can go the other way, and you can go down to Port Rowan. So there's Port Dover, Turkey Point, Port Rowan, and Long Point here. Down at the waterfront, there's a park in Port Rowan, nice and open there, lots of room to park, and you could observe the eclipse from there, or you could drive down the road that goes along Long Point, and there's some actual parking areas there where you could stop and be even closer to the center line. From downtown Port Rowan, you get 3 minutes, 24 seconds. And the bonus to this particular location is that by car, for a lot of us, it's probably equidistant and time-wise, and the driving is a heck of a lot easier. And there'll be way fewer people, hopefully. Anyways, 3.5 minutes almost from Port Rowan. And the odds of seeing it are the same as everywhere else in Ontario. Not great. However, we live and hope. So, timeanddate.com on the internet. Look it up. It's an awesome website, and you can print out calendars, and you can You can find out what's going on with different time zones, the world clocks. There's all kinds of cool stuff. Now, last month, I did the sky this month. I really did the sky this month, right? And we went around part of the sky and looked at a bunch of targets. And one of the questions I got was, you know, you make it sound so easy. You just look up and down or left and right. And there's a lot of truth to that. But you have to have some idea at least as to where those lines of up and down and left and right are. So if you go out at this time of year, in fact, anytime during the winter, right through into about early March, and you look somewhere between southeast and south, you're going to see this view. Maybe one day when it's actually clear and you can see anything. But this is what you would hope to see. And what I want you to do is, if you're not good at reading the sky yet, is learn a few bright stars, because they help you to find your way around. So if you're facing southeast and you look low in the sky, you're going to see Sirius, the dog star, or Canis Major. And that's a great star to start with because it's low and it's almost due southeast right now. And it's really, really bright and it twinkles. It's so low in the atmosphere, you get a lot of twinkle from it. You should be able to pick that one out. Most people next to the Big Dipper, Orion in the winters, the constellation they recognize the most. So if you're looking up from Sirius and kind of to the right a bit, like at 1 o'clock, you're going to find Orion and the very bright stars Rigel and Betelgeuse and the belt stars. So once you know Orion, well, then you can bomb straight up from Bellatrix and find Aldebaran, which is the red eye of the bull of Taurus. And from there, you can go up and find the Pleiades. So right away, you've already gone straight up and for the most part, and found very bright stars and a couple of clusters, including the Pleiades and in here, the Hyades. Now, what I want you to do is get up to the Pleiades, move to your left, which is east, until you hit Capella. Capella is a very, very bright star. And once you find Capella, you can then, if you're in a spot that's dark enough to at least see some of the marker stars, you can pick out the shape of Auriga. And from there, you can come down and to the left and find Castor and Pollux, again, bright stars. Those are the twins in Gemini. And then from there, you head back down towards Sirius in this line. Only go halfway. So if I figure out how long that line is in your sky, go halfway, stop, look down just a bit, and there's Procyon and Canis Minor. And now you have found basically all the winter bright stars that you're going to be interested in to look at a ton of targets. And these stars will help you give you points at which to start looking at the objects you're looking for. If you can find those stars, then you can start to learn a few of these constellations, just some of the basic layouts of them, how they look. Once you have those extra markers of all the other stars in those constellations, it makes a huge difference. Another thing I want you to notice is if you look to the left third of the screen here, there are no bright stars. There's a whole big piece of the sky with rather dim constellations. In fact, the brightest is probably Leo, and that's not really high enough in the sky at this time of year to really worry about it. And the brightest star there is Regulus. Generally, that's kind of a dead area of the sky at this time of year, along with the other side over here. So right along the Milky Way, it's where you're going to see all the cool stuff. And so learn the bright stars, learn their names. You don't need to learn 10,000 star names. No, 20 of them in a season might be really helpful, or 15. And then how do those constellations sit compared to each other, and learn how to point from one to the next. And from there, once you can see those things, and then all that up, down, left, right, looking for things is going to make a lot more sense. One of the other things that kind of people find a little disconcerting is how far apart things are actually physically in the sky. Things on a chart like this don't look like they're too far away, right? From there to there, it looks too far, but it's like 25 degrees, 30 degrees. How do you know you haven't gone too far and you're looking at totally the wrong thing? Well, it turns out fingers on your hand are excellent at giving you guideposts to angular distance across the sky. So if you only need to move 1 degree in the sky, you put up a finger and that's 1 degree. If you need to move 5 degrees, up 3 fingers. That's all arm length. A fist, 10 degrees. Your first finger and your baby finger, 15 degrees spread out. And then if you go your thumb to your baby finger, 25 degrees. This chart and other ones very much like it are everywhere on the web. You won't have any trouble finding this. Your hand size, your lengths, everybody's slightly different. You may find out that if you spread your fingers all the way out, that you're really at 28 degrees or you're only 22 degrees. But this is really pretty much close enough for most people. And you'll notice that they use the Big Dipper to represent 25 degrees. So another chart that is everywhere on the web, just have to sort of look it up. You find out that the Big Dipper is great for giving you 25 degrees, 15 degrees, 10 degrees, 5 degrees, all these things. So you can actually, when the Big Dipper is a little more visible in the sky than it is right now, where at times it's right down at the horizon. But once you got a good clear view of it, you can actually just compare this chart to how your body and fingers work, and you can figure out then this is across the sky. So if 2 stars are 30 degrees apart, you know it's going to be 25 degrees with your fingers spread out, and then another 3 fingers held up. It's going to get you close enough to where you want to go. So that's large scale angular measurement across the sky using your fingers at arm's length. Now I'm going to talk about angular measurement that you see through your eyepiece. And that angular measurement is called the actual field of view. And then here I put, and all that implies that I wrote that. It just goes to show how my brain kind of wanders around, because when I wrote all that implies, I thought, that's from a movie. What movie is that from? And I couldn't concentrate until I figured that out. It turns out it's from The Iron Giant. It just goes to show I'm not the most focused individual in the world. Anyways, so you're going to hear 2 terms a lot when you start reading about this stuff. You're going to hear about apparent field of view, and you're going to hear about actual field of view. Apparent field of view, what is the angular measurement that's listed on eyepieces? Okay, not binoculars. That's a bit different. I'll talk about that in a sec. But on eyepieces, you'll see numbers like 100 degrees, 68 degrees, 50 degrees, 44 degrees, all kinds of numbers. And it's really just a relative number that tells you that you're going to see more sky when you look through the eyepiece or less. You're like, are you looking through a straw, or are you looking through a paper towel tube, right? How much are you going to see? So binoculars are different. Field of view that's on binoculars is the actual field of view that you will see. So if the binoculars say that they are 5 degrees field of view, then if you looked at 2 stars that are 5 degrees apart, they'll be at the edges of the field, one at one side and one at the other. Get a real 5 degrees. The number that's on the eyepieces, in terms of how you would use that to actually look at the sky, it's rubbish. It has a use, okay? So as examples here for actual field of view, binoculars generally, wide angles are 7.5, normal binoculars 5 to 6 degrees. If you're into binoculars, it could be down anywhere between 2.4 and 3.5 degrees. So obviously more magnification involved, those great big honking binoculars, right? Telescopes, if you have a short refractor, you could have 2 degrees of the sky that when you look through the eyepiece. Most medium magnification eyepieces on your average home telescope, you're somewhere between about 0.7 and 1.2 degrees, which isn't bad. Last example there, the 0.25 degrees. Oh man, you don't want to try and star hop with your eyepiece if you're at 0.25 degrees. That means you got a super high powered eyepiece in there, and your field of view is going to be tiny. So that's not what you want to do. So the reason you really want to know about the actual field of view is because different targets are different sizes. So if you were to look at, say, a planetary nebula that's 1 arc minute across, that's going to be very different than looking at the moon, which is 30 arc minutes across. You're going to want a different combination of telescope and eyepiece, because you want, if you're looking at a planetary nebula that's only 1 arc minute across, you're going to want lots of magnification so you can actually see it. If you want the moon and you did that same eyepiece, you'd be looking at a few craters if you were lucky. So matching field of view that you expect to see with target you're looking at and the size of the target is very helpful. So this is not difficult. Hint says it's easy, and it is. So first you need to know the magnification that the eyepiece and telescope combination you are using is going to give. Every eyepiece and telescope combination is going to give you a different magnification and field of view combination. So the first thing you want to know is magnification. I think most of you know how to do that, right? You take the focal length of the telescope, which is the number that's written on the tube. It could be 400 millimeters or 900 or 1.2 meters or 2 meters. It'll be on the tube. And the other number you need is the focal length of the eyepiece. So I use an example here of a 900 millimeter telescope, 25 millimeter eyepiece, and the magnification is 36 times. So one thing to remember is if you have an eyepiece that says it's a 60-degree apparent field of view and another one that's the same focal length that says it's a 100-degree field of view, it's still going to be 36 times if they're both 25 millimeter eyepieces. It's only how much sky you can see, but the magnification effect is the same. Now you want to figure out that actual field of view. So this is not a hard calculation either. You've already figured out the magnification. Now you look on the eyepiece and you see what it says. So it might say 60 degrees. That would be most super plosives. You divide it by the magnification. And in the example here at the bottom, you can see a 60-degree eyepiece divided by 36 magnification gives you 1.67 degrees of sky. That's how much you're going to see. So if you look on a chart and you're looking for two targets that look like they're really close together and they're less than 1.67 degrees apart, you could fit them in the same field. If they're further apart than that, you've got to start moving the eyepiece around. So I thought I'd give some examples and also an easy way to do this instead of having to figure it out yourself. Let's start with the Rosette Nebula here. Now, if you were looking through an eyepiece, I've picked an eyepiece and a telescope here, and you had the right combination, you can see the whole Rosette Nebula in the field of view, and that's about 2 degrees. And by the way, to see that, you'd need a nebula filter as well, because it's a hydrogen region, but just pretend that it's really easy to see like this is, okay? So now you're saying, well, I can't read anything on that screen, it's too tiny, and you're right. So from the top right-hand corner here, I've blown that way up. So what you can see is I've got the eyepiece I chose is a Nagler 31 millimeter with an apparent field of view of 82 degrees. All right. Magnification that is calculated is 40. And I'm using a Celestron C5 telescope. That's one of those little orange tube Schmidt-Cassegrains. So you get 40 magnification, and then look at the bottom here. Field of view, 2 degrees. And that's what you're seeing over here in this image is a 2-degree field of view. It just nicely encapsulates the Rosette Nebula. And you know, your eyepiece, your telescope, and it tells you the rest. So here's the next example. And in here, you can see the red ring. It's not that easy to see against the red nebula, but it's there. And the field of view that you're seeing with this combination is the same telescope, different eyepiece. And look at that, you're just looking at the core of the nebula. You're looking at the NGC cluster that's in the middle. So again, I've blown everything up. The telescope, like I said, is still the Celestron C5 Schmidt-Cassegrain. The eyepiece is an 8.5 millimeter instead of a 26. The apparent field of view is still 82 degrees. All right. And that's the number that you need to figure out the real field of view, the actual. But this has done it all for you. And you can see your magnification now because you've gone to a much shorter focal length eyepiece is 147. And you can see the field of view is down to just about 0.6 of a degree from 2. So if you were to take the same example and apply it to, say, the Pleiades, which is a nice open cluster, which in binoculars or in a really low power, short refractor looks just awesome. If you were to use the wrong eyepiece, you might only see 2 or 3 stars in the center of the Pleiades and go, that's not awesome. That's just 2 or 3 stars, because the object looks better, less magnification, and a bigger field of view. And this is another example. I'm trying to move along here. I've kept the same high power magnification eyepiece, 8.5 millimeter. It's still got an apparent field of view of 82 degrees, but I've changed telescopes and I've gone to a little shorty 80 millimeter refractor. It's probably only 400 millimeters long. And because I chose a much smaller, shorter telescope, I get way less magnification. Instead of 147, I get 47. And my field of view is back to up almost 2 degrees again. So the combination of the eyepiece, the apparent field of view of the eyepiece, in this example, 82 degrees, and then the telescope you're using, the focal length of the telescope, all work together. So your combination is going to be different from anybody else's in the club, depending on what stuff you own and use. So in general, shorter focal length eyepieces provide more magnification. But magnification is dependent on the telescope focal length, how long that tube is, and the eyepiece focal length you're using. And the same eyepiece on different telescopes will provide different magnifications and actual fields of view, unless you happen to pick 2 totally different telescopes that have exactly the same focal length, in which case, sorry about your luck, you're looking through one, it's going to look a lot like looking through the other. Generally, most of us that own multiple telescopes are all different designs, different focal lengths. We have different sets of eyepieces with different apparent fields of view. And so it's really nice to be able to know what to expect to see when you look through the eyepiece. So please tell us there's an easier way, and yes, there is. Again, back to the internet to save you, astronomytools.com. It's been around a very long time. It's also very useful. And one of the things it talks about is the field of view calculator down here. I'm going to skip a screen here, and I've just sort of cropped it so you can see more of what you would actually fill in. So pick a target. It could be a Messier, it can be a planet, it could be an NGC or an IC object. It's got pictures of, or images of tons and tons of targets. Pick one. I chose M13, the big globular in Hercules. I picked an 8-inch, 200 millimeter knob. I picked just a 26 millimeter eyepiece. It's very common, 8-inch knob, 26 millimeter eyepiece. And the field of view, the apparent field of view of the eyepiece, in this case, is 70 degrees, which is also very common for some of these eyepieces. As soon as you pick all that, and you come down here, it's going to give you the magnification. It's going to give you the real actual field of view, 1.82 degrees that you're going to see in the eyepiece. Excuse me. And you don't have to have your exact brand of 26 millimeter 70-degree field of view eyepiece. Because remember, all these companies make that sell you eyepieces. If they have a line of eyepieces that's 70-degree, there's a really good chance it's exactly the same eyepiece as another company is selling, and one is green and one is blue, but other than that, it's the identical optics. So you just have to replicate or get close to what you have in your case. It doesn't matter about the brand as long as the specs match or are darn close. Anyways, once you picked all this and it's told you all this stuff at the bottom, you click on this button over here, add to view. And what comes up is this. So the red line is the outer edge of your field of view that through the eyepiece. So if you can see right to the edge of the field of view of the eyepiece, you see that black ring. That's what you would see. And the Hercules cluster is just in the middle there. Not very impressive at this point. If you've never seen it before and that's all you've got, still awesome. It could be more impressive. So you go in again and change eyepieces, right? So we're going to go to a 5mm eyepiece with only a 60-degree apparent field of view. And when you do this, the magnification ups to 200, the field of view drops to only 0.3 degrees. You add it to the view on your screen, and this is what comes up. The outside ring is now green, but don't worry about that. That's your first eyepiece that you chose, the 26mm, and the yellow ring down here is the 5mm eyepiece. So logically, you can look at that and say, wow, Hercules pretty much fills that field of view for the 5mm eyepiece, but doesn't look so hot with the 26. Some people have an issue with trying to visualize that, just what it would really look like. So you can get rid of your choices, any or all of them. So if I want to get rid of this one on the outside, I go over here and I click on the 26mm option, exit out, and that outer ring disappears and it comes up again like this. So now all you're seeing is the field of view with a 5mm eyepiece, and you're looking at the Hercules cluster and going, oh man, that's just so cool. And you can see thousands of stars while you're doing that. So that gives you an idea of why I think it's important to understand what the numbers mean on the eyepiece, what they mean on the telescope, how does it affect your viewing, and also when you're researching targets, how big is that target, and what optics do I need in order to be able to resolve it to some extent so I can see some detail. Lastly, I had a look at the Event Horizon newsletter. Bob, as always, has done a great job. I encourage everybody to read the Event Horizon newsletters. There's always really cool stuff in there. Joanne is covering the upcoming eclipse and it has a really neat word search. Steve German is talking about the planets you'll see in the morning right now, including Mercury, talking about the bright comets there's a couple of them that you can search for and photograph. The upcoming meteor showers. Doug Curry has had a multiple part discussion about binary star systems. This one concentrates on the planets. It could be habitable planets that are around binary star systems. And Chris Sabin, under the eye candy section, has the bubble nebula. He has the hydrogen regions in Auriga, and he has a nice shot at Jupiter. So, you can choose what you want to read. Have a look at the Event Horizon, and if you are interested in the older ones, they're all there. You can go way, way back in the time machine and read what other people have written. And sometimes you can go back multiple years. You could go back to January a bunch of years ago and see what whoever was writing the newsletter that month, what they wrote about the sky that month for that January. And the thing is that other than the positions of the planets, your other targets are all going to be there, right? So you can actually get a cross section of people's ideas of what's important to look at or what's interesting to look at just by reading through some of the old Event Horizon newsletters from years gone by for the same month, or, February is coming up, look up February for a few years and see what people wrote. It's interesting. That's the end. I don't know if there's any questions.
Thank you, Matt. Well, thanks, Matt. There, that's better. That
Still
was
here.
awesome. Does anybody have any questions for Matthew from here or in Zoom? I can see in the Zoom people, they've been discussing the different apparent and actual fields of view of the various eyepieces that they've been chatting about. I don't see any questions here from the back. I don't see anything from the back. So we're just going to pop that down there. And that brings us to the end of our meeting this evening. We're just going to pop up our last slide for our upcoming events. And with that, thank you for coming out and braving the weather tonight, everybody. Thank you for everybody who's been there in Zoom. We appreciate you being there. Thanks to everybody who has presented tonight. It was excellent. For those of you who aren't here, we will have eclipse glasses at the next meeting, so you can pick yours up then. With that, I'm going to say good night to everybody on Zoom and everybody here. Safe drive home. And for those of you in the room, we have to put the chairs and the tables away. So the chairs stack about 8 or 9 on the rolling carts that are on the side. So before you go, if you could just take a couple of chairs and stack them for us, that would be awesome. And safe drive home, everybody. And we'll see you in February.
Good night, everyone on Zoom. We're going to